A more interesting problem is for two or more ropes to support a stationary object by exerting forces at an angle. So we're going to focus on tension, and we're going to use subscripts 1 and 2, and we're going to replace Ft with just a capital T. So in this case, it's at rest, and so the acceleration is 0, so sigma F equals 0. Where would you see this outside a physics classroom? In the cables that hold traffic lights over the street. You've probably seen them other places as well. Since these forces are at an angle, we need to break them up into x and y components. So this is T2y, this is T2x. And do the same thing for T1. T1y and T1x. Since the only other force on the object is gravity, the vertical components of the force exerted by each rope must add up to mg. And now the only forces in the x direction are those that are provided by the x components of T1 and T2. And again, the object isn't moving, so T1x equals T2x. We will be dealing with only the magnitudes of the various tension components. We already took into account the directions when we made those two equations. And always remember to draw a free body diagram. That way you won't have to worry about angles greater than 90 degrees, and you won't have to worry about whether or not to use sine or cosine. You can just look at your diagram.